Hi everyone. Today, here I am going to take the seminar on the topic fly ash. First of all, we should know what is ash. Ash is the byproduct of coal which is produced after burning it. It is a versatile material which can be used in a variety of applications. There are different types of ash: fly ash, bottom ash, pond ash, mount ash. Our topic is fly ash. This kind of ash is extracted from flue gases through electrostatic precipitator in dry form. This ash is fine material and possesses good pozzolanic property. Here we can see the classification of fly ash: class C fly ash and class F fly ash. Color may vary mostly depending on the iron, carbon and other impurities. What is fly ash? Fly ash is the finely divided residue that results from the combustion of pulverized coal and is transported from the combustion chamber by exhaust gases. Components of fly ash. It consists of oxides of silicon, aluminum, iron, and calcium. Magnesium, potassium, sodium, titanium, and sulfur are also present to a lesser degree when used as a mineral admixture in concrete. Fly ash is classified as either class C or class F ash based on its chemical composition. When fly ash is used in a mineral admixture based on the chemical composition, it is classified into class C and class F. Where is fly ash used? Currently, over 20 million metric tons of fly ash are used annually in a variety of engineering applications. Typical highway engineering applications include Portland cement concrete, PCC, soil and road-based stabilization, flowable fills, grouts, structural fill, and asphalt filler. The major uses are Portland cement concrete, in asphalt concrete, in stabilized base and embankment and fill material. Next, we can go through the properties of fly ash. There are chemical properties, physical and structural properties, pozzolanic properties. First, chemical composition. The major constituents of most of the fly ashes are silica, alumina, ferric oxide, calcium oxide. The other minor constituent of fly ash are magnesium oxide, sodium oxide, potassium oxide, sulfur trioxide, manganese oxide, titanium oxide, and unburnt carbon. There is wide range of variation in the principal constituents like silica 25 to 60%, alumina 10 to 30%, and ferric oxide 5 to 25%. Next, pozzolanic properties. Fly ash is a pozzolanic material which is defined as siliceous or siliceous and aluminous material which in itself possesses little or no cementitious value, chemically react with calcium hydroxide or lime in the presence of water at ordinary temperature and form soluble compound comprises cementitious property similar to cement. Structure and physical properties. Spherical glassy particles form due to rapid cooling of molten ash in the furnace. Apart from the solid spheres, there also may exist hollow spheres. The small hollow spheres with entrapped gas is called cenospheres. A large hollow spheres with solid spheres inside them is called pyrospheres. Particle size is between less than 1 micrometer and 100 micrometer. Plane specific surface is usually between 250 and 600 meters square per kilogram. Benefits of fly ash. Fly ash can be a cost-effective substitute for Portland cement in many markets. Fly ash is also recognized as an environmentally friendly material because it is a byproduct and has low embodied energy. the measure of how much energy is consumed in producing and shipping a building material. By contrast, Portland cement has a very high embodied energy because its production requires a great deal of heat. Fly ash requires less water than Portland cement and is easier to use in cold weather. Other benefits include produces various at times, cold weather resistance, high strength gains depending on use, can be used as an admixture, considered a non-string material, produces dense concrete with a smooth surface and sharp detail, great workability, reduces crack problems, permeability and bleeding, reduces heat of hydration, allows for a low water cement ratio for similar slumps when compared to no fly ash mixes, reduces carbon dioxide emissions. Next, disadvantages. Smaller builders and housing contractors may not be familiar with fly ash products, which can have different properties depending on where and how it was obtained. Additionally, fly ash applications may face resistance from traditional builders due to its tendency to effloresce, along with concerns about freeze or thaw performance. Other concerns about using fly ash in concrete include slower strength gain, seasonal limitation, increased need for air entraining admixtures, increase of salt scaling produced by higher proportions of fly ash. These are the disadvantages of fly ash. Collection of fly ash. During combustion of coal, 75 to 80% of ash flies out with the flue gas and is thus called fly ash. The ash that doesn't fly out is called bottom ash. This can be processed as aggregate but is generally not used in concrete. Collection of fly ash is done using two types of precipitators, the baghouse precipitator and electrostatic precipitator. The baghouse precipitator is found to be more efficient than electrostatic precipitator and removes out very fine material. These are the pictures of production of fly ash. Generally, fly ash benefits fresh concrete by reducing the mixing water requirement and improving the paste flow behavior. Resulting benefits are as follows: improved workability. The spherical shaped particle of fly ash act as miniature ball bearings within the concrete mix, thus providing a lubricant effect. Fly ash is a pozzolan, a substance containing aluminous and siliceous material that forms cement in the presence of water. When used in concrete mixes, fly ash improves the strength and segregation of concrete and makes it easier to pump. When fly ash used in concrete mixes, it improves its strength and segregation of the concrete and it is very easier to pump. Typically, 15% to 30% of Portland cement is replaced with fly ash and with even higher percentage used for mass concrete placements. An equivalent or greater weight of fly ash is substituted for cement removed. The substitution ratio for fly ash to Portland cement is typically 1:1 to 1.5:1. This is the percentage of fly ash used in concrete. Specialized applications. In high strength concrete, it is used as an additional cementitious material. In roller compacted concrete, fly ash is good for bonding in between the layers of this concrete. In controlled low strength material, which are flowable mortars used as backfill, as a synthetic aggregate for manufacture of bricks. Influence of fly ash on fresh concrete. Improved workability and flowability of concrete. Due to the spherical shape of the fly ash, particles which has a ball bearing effect due to the reduction in size and volume of voids because of finely divided particles. Therefore, paste demand decreases. Reduced bleeding and segregation for well-proportioned fly ash concrete. Next, influence of fly ash on hardened concrete. Creep and shrinkage of fly ash concrete are typically lower than normal concrete. The lower amount of paste in the concrete, resistant against corrosion, alkali aggregate reaction and sulfate attack is increased. Less permeable and porous microstructure and reduced Portland cement content. Ultimate strength are reached much after 28 days. Strength gain due to pozzolanic activity of fly ash concrete is lower than normal concrete, that is up to 28 days due to particles less than 10 micrometer in diameter, after 28 days due to particles between 10 and 45 micrometer in diameter. This leads to lower thermal cracking. What is high volume fly ash concrete? The concrete with 50% of the Portland cement replaced by class F fly ash is called high volume fly ash or HVFA concrete. Low water content, generally less than 130 kg per meter cube. For slums of 150 to 200 mm, the use of a superplasticizer is mandatory. Range of compressive strengths 20 to 50 megapascal. Excellent pumpability and little bleeding and low drying shrinkage. Some applications of HVFA concrete are used in mass concrete blocks, building columns and foundations, caissons and piles, dams, highways, shotcrete and self-compacting concrete. There are some examples of fly ash in concrete. Fly ash concrete was used in a Prudential building, the first tallest building in Chicago after World War II. Fly ash has been used in construction of world's tallest building, Petronas Towers of Kuala Lumpur. The concrete used in the building was of two grades, 80 megapascal and 60 megapascal. The fly ash content was about 37 to 5% of total cementitious content in mix. The construction was completed in the year 1998. About 60,000 cum of fly ash concrete with an estimated saving of 3,000 ton of ordinary Portland cement was used in Ludnock Dam construction in UK during the year 1955. Next example is the fly ash concrete is used in Bandra Worli sealing project for trimix seal concrete and pile cap concrete. These are the fly ash bricks or blocks. Next, salient advantage of using fly ash in cement concrete. Reduction in heat of hydration and thus reduction of thermal cracks and improved soundness of concrete mass. Improved workability or pumpability of concrete. Converting released lime from hydration of ordinary Portland cement into additional binding material, contributing additional strength to concrete mass. Pore refinement and grain refinement due to reaction between fly ash and liberated lime improves impermeability. Improved impermeability of concrete mass increases resistance against Improved impermeability of concrete mass increases resistance against ingress of moisture and harmful gases, result in increased durability. Reduced requirement of cement for same strength, thus reduced cost of concrete. I hope you understand the class, and thank you.